All right. So sorry about that. Just to recap, we're told that theta, given in standard position, if the terminal side of theta lies on y equals 2x and x is less than or equal to 0, y equals 2x has a slope of 2 with a y-intercept of 0, so that would be this little blue line here. So this would be like y equals 2x. And because x is 0 in quadrants 2 and 3, we know that our triangle is going to lie right here. Now, technically what they're saying is, and we talked about this before, from standard position, this is the standard position, theta actually goes all the way around here. Or you could take the negative theta, which goes to here. Or you can focus on what we call the reference angle. Okay, this is what we're going to do most of the time. But we have to keep track of the positive and negative numbers. So there's one little thing that I need to mention. So when I think of the x comma y, right, remember that this is equal to 2x, right? So when you think of this, our y value is equal to 2x. And then our x value is actually a negative x value, so you would say negative x. Okay, we need to keep track of that to some degree to get our points right. So now, what does that mean? Well, I suggested that we plug in a number, right? So we could make this actually the point 1, comma 2, but you can't make it 1, comma 2. It has to be negative 1. Whoops, got a little gung-ho on the negative sign. So what does that mean? Well, if I let x equal 1, then y would equal 2, right? Well, we'd say negative 1. Actually, it'd be negative 2, right? If I plug in the numbers. Okay. Now, I prefer plugging in the numbers here because the negatives, I don't know, I think the negatives would throw you guys off because here we don't have a negative number. This is just a relationship between y. See, they're telling you that x is negative, right? So I just prefer if we put in negative x and negative 2x, the negatives are going to cancel in some cases. The x's are always going to cancel. So I just like putting in the numbers. So this is when x equals negative 1, y equals negative 2 on this line, right? So from there, if I think in terms of theta, then I would say sine of theta is equal to the opposite over the hypotenuse. Wait a minute. Before I do that, what do I need to do? I need to find the hypotenuse. So remember that this is the opposite, this is the adjacent, and r is the same as the hypotenuse. So we could write this a couple of ways. The Pythagorean formula is a squared plus b squared equals c squared, right? And I do want you to write this down. Or in terms of trigonometry, it could be the opposite squared plus the adjacent squared is equal to the hypotenuse squared, right? Or in terms of the xy plane, it could be y squared plus x squared equals the radius squared. And this is actually the equation of a circle. Do you guys remember that? Anyways, so, well, what is that then? Well, if this is going to be y over r, I need to find what r squared is. So I'm simply going to plug in the values. So I'm going to say negative 2, that's what my y value is, plus negative 1 squared is equal to r squared. Negative 2 times negative 2 is a positive 4. plus -1 times -1 is a +1. All that equals r squared. I'm going to take the square root of both sides, and I get the square root of 5 is equal to r. So, oops, we'll leave that up here for a second. So my radius of my circle, or the hypotenuse of my triangle, is actually the square root of 5. And so my y value is -2 all over the square root of 5, right? So now what do I do? Can I leave that square root in the bottom of a fraction? I see some heads shaking no. So what do I do to fix that? Yep. We're going to rationalize the denominator. I have to multiply this by the square root of 5. Whatever I do on the bottom, I also have to do on the top. So I get a -2 root 5 over 5. Okay. Let's do cosine. Cosine of theta is the adjacent over the hypotenuse, but in terms of the xy plane, it's x over r. And our x value was just 1 times the square root of 5. And from here, we could just rationalize the denominator. And we get the square root of 5 over 5. Now, you know what I'm going to do is, before we go any further, this is what it is when we first plug it in. So when we go to do the reciprocals, this is the only part we need to flip, right? The parts before we rationalize our answer, okay? Let's do tangent real quick. So tangent is the opposite over the adjacent, which is actually the y over the x, which is -2 over negative. Oh, wait, this is -1, right? Oh, guys, you got to catch that. See that? All right. So then this reduces down to 2 over 1 because these will cancel. And that's just 2. Again, when we go to do our reciprocals, we're just going to flip these. So what's the reciprocal of sine? Cosecant. Cosecant is the hypotenuse over the opposite, which is actually the radius over y, which is really just the square root of 5 over -2, but we'll just toss the negative in the front, right? What is the reciprocal of cosine? Secant. Secant is really the hypotenuse over the adjacent, which is really the radius over x. We're just going to flip this right here, which would be -√5 over 1, or -√5. Tangent not tangent, cotangent. I haven't had my coffee. I had a doctor's appointment before school, and I did not have my coffee this morning. Everything's fine, by the way, if you're wondering. And so we're just going to flip this. This just becomes a +1/2. Okay. How do you guys feel about? Let me word this question. Do you feel better about this now